Hey everyone, welcome to this the C++ live stream. So I've called this Sane C++, but I was thinking about it, I could equally call it simple C++, because that's really what I'm advocating. It's just a way of using C++ which is simple, productive, and gets the job done, and is enjoyable to program in. I actually really enjoy programming in C++, at least the way I use it. So, hang on a minute, is everyone joined? Cool. So, why do we program in C++ and not C? C is pretty much the fastest code. You can't really get faster than straight C. It's very hard to shoot yourself in the foot using C. C++ is a lot more complex, and it's very easy to do things that have a big performance penalty without realizing it. And so we don't use C++ because it's faster. And most people know that, but I think it's worth pointing out. We're using C++ because, in theory, it makes it easier for us to write code and for us to maintain code and sort of to write complex to model complex problems in a simpler way. And if it doesn't do that, it's not doing its job, because we might as well just go back to C and write very fast, simple code. So what I want to stress is that you don't have to use all the modern features. Especially if you're still learning C++ or not that experienced, you kind of see other code and you think, oh, I've got to use all these different features, otherwise I'm not a real C++ programmer. And that's really not the case, and that's what I want to make clear here. So let's get into it. There were a few things that came up from the last stream or the one before. One was my use of assert code. And I'll just find an example of this for you. Yeah, that'll do. So this is not my assert. My assert is just assert. It's just one of those. And there's a bit of confusion as to what that was. I mean, this is basically just a statement that's compiled out if asserts are turned off. So this is only compiled in if asserts are enabled. And that's important for stuff like, let's have a look. Debug info, that's probably a better one. Can you see that? So something like this, you've got debug info in a class, and you don't want the overhead, you don't want to increase the class size in release. So what I would do, instead of doing that, just that. Now I think probably most of the confusion was because it's a badly named macro. Someone suggested it should be called enable if asserts, and that'll be much better. I think I probably will change that. But that's basically what it does, and it's a useful thing to do just to get rid of code you don't want in release. Anyway, so that was that. So I do want you to ask questions as we go for those on the live stream, because those kind of things are so useful, because they're things that I don't think to tell you, but you just happen to notice when I'm scrolling through my code. And I think those are the most valuable things, and that's why I want to, as much as possible, keep this to be me going through my code, talking about various stuff, because it's real code, and looking at real code is definitely the best way to learn. So yeah, keep asking questions as we go along. Enum Class, I won't really go into those today, but there was a question about using Enum Class. So rather than using the old style C type enums, you can use Enum Class, which is a proper scoped enum in C++. And it has one drawback, that you can't combine the values. Let's have a look. I think, no, def type, let's try that. So here we've got an enum, which is just basically a bit field, and you can combine them with or, so you can, you know, do, so you can see it. You can combine them like that. But the problem is with C++ enums is you can't do that by default. You have to create these operators to actually do that. And it's a bit of a pain. But for me, it's worth using Enum Class. It has certain benefits over the old style C enums. So that's one case where I have taken the modern C++ way of doing things. I think it is better. And I'm gradually converting my codebase over. But anyway, that's how you do it. You just have to use operators to do that. So anyway, I'm not going to concentrate on Enum Class today. It's not that exciting. I did say I was going to talk about R value references. I'm not sure about that now because I think I'm going to end up spending a longer time talking about lambdas. So maybe I should do lambdas first, and if we've got time, we'll get onto R values, or if not, we can do R values next week. So let's get into lambdas. Now I have just created some test examples here. I kind of did say I wasn't going to use just created simple examples because they're not as good as real code, but I don't have any lambdas in my code, so I kind of need to create something to show you. So I've created a few examples here to talk about, and then I've added in my code base. I've compared using my function class to using lambdas. Now, lambdas are useful. I mean, I'm not going to explain lambdas. I'm going to assume you know about them. But they're kind of useful for two things. It's worth clarifying. One is inline code. I don't mean inlining in a compiler. I mean seeing code in the flow of code that you want to do. So, for example, yeah, I can't. Let's have a look. Just reminding myself of all the examples I've got. So basically, say we've got a find class, a find function, sorry. What I mean by inline is this code is actually as passed as an argument to the find. So you can have a function which is right there rather than somewhere else in the file, and supposedly it makes it easier to see what's going on. So that's what I mean by inline code. And also capturing is very powerful because you can capture arguments, and if you don't use lambdas, it's kind of more tricky. You've got to do some actual code to do that. So capturing is very useful. So those are the two reasons you might want to use lambdas. Now, personally, I don't use lambdas, and I'm not totally against them, but I've just never really seen the need for them. So I very, very rarely ever want inline code for these things. I would always rather create a function, put it somewhere else, and then just reference that in some way. So I maybe have a handful of occurrences in my entire code base where arguably I could use a lambda and make it slightly clearer. But that would involve adding lambdas to my language. As I was saying in the last stream, I have a language. This is very simple, very reduced set of C++. And it doesn't have lambdas at the moment. I mean, I could add them, but it doesn't have them. And for the small amount of times a lambda might make things slightly clearer, I'd be adding a whole feature to my language and I'd have to remember how to use it, and I probably wouldn't use it enough to actually remember the syntax or get used to typing it. I mean, even when I was creating these examples, I kept on leaving off the bracket or the semicolon at the end of the lambda because I'm so used to just functions. It just, obviously you get used to it over time, but I probably wouldn't use them enough to actually get used to it, and it would just be an annoyance. And there are other ways to capture variables. So you don't need lambdas. Let's have a look at a very simple case. So let's ignore all that. Let's just boilerplate code to get it working. Let's just say we've got a lambda that does that. So the first thing to notice is if you're declaring a lambda and assigning it to a variable, you've pretty much got to use auto. There is no type for lambda. If you look at the compiler, it will just have some lambda hash number of class or whatever, some weird thing which the compiler creates. So the compiler will create a struct, a local struct with a random name, and then use that. So you can't actually reference a lambda. You can't actually set the type of lambda. So suddenly, by putting in lambdas, I'm now using auto. And like I said in the last stream, my language doesn't have auto. So I would have to add that conceptually to my language. So that's a bit of an annoyance. It's not so nice. So then we got the capture and then the arguments and then the actual body. Now, I mean, some languages do have better Lambda syntax than this. I don't particularly like this. The C# syntax is a lot better. When you're not capturing anything, you don't have any arguments, it's a bit weird to say this is what a lambda is. 2 square brackets and open, close bracket. Okay, not that good so far. So this is just calling lambda, calls it there, etc. Now I just thought I'd compare that with my function class, which I think I've mentioned before, which is basically the same as similar to std function. And I know it's a different thing than a lambda, but that's how I might do it here. So I'm just saying it's a void, doesn't have any arguments, that's explicit. I think that's clearer than that. And it's just passing in a function, and then that calls it. So they're equivalent. So someone said that Lambda syntax is like typing characters to see if a font right looks good or not. Yeah, it just looks weird to me. I mean, I know you get used to anything if you have to. So someone says no capturing Lambda has a well-known type. Actually, I didn't know that. That's interesting. So I'm probably going to embarrass myself here because I'm not incredibly well up on Lambdas because I don't use them. I know them well enough to use them in other code that I work on, but I don't use them in my own code. So yeah, if I get anything wrong, please let me know. So yeah, it's void, open, close bracket. Okay, that's interesting. But anyway, in more complex Lambdas, you definitely need auto. And the other thing is to get the best performance, you have to use a template. So I'm passing a lambda into this function. You kind of have to use a template because you don't know the type of it up front, unless it's a void, like as you said. That's not ideal because you're not giving any information, and it's not kind of as type safe as it could be. I mean, the other thing is you can assign it to an std function, but that's not great from a performance point of view. Often you do want the actual lambda rather than, if you use std function, you're creating allocations and doing all sorts of complex stuff. So I just thought I'd show you an example. I mean, it's fairly basic, but if you didn't have lambdas, and this is how we used to do it, and this is essentially what a lambda is doing, or at least the simple version of lambda, it's just creating an inline struct. So I've got this function, I have a struct, and give it a function operator. And let's make that a bit bigger. So then you declare a class of that function, call find, and pass in that struct. So when you do array.find, that's the lambda, and then it just uses that to say, is that the item we're looking for? Very simple. So that's one way of doing it if you don't want to use lambdas. And that works in straight C as well, I think. So if you want to capture a variable, obviously you just create a constructor, create a value, pass it in. So here we're just passing in the value we want, capturing that, and then passing in the lambda, and then obviously it uses that captured value when it's doing the compare. So that's essentially what a lambda is doing, and it's very simple. And I would argue, I mean, in my code I have actually done this a few times. I've created a struct just so I can see the code in line, because obviously you could create a function instead outside of here, but sometimes it is useful to see stuff in line where you're actually using it. So I want to know what it is I'm looking for when I do a find. And in some cases that is clearer to do, I think, than a lambda, because it, you know, if the function gets bigger, because a lot of these things, they're fine when the function is small. I mean, not that one. That's fine when the function is small, you can just fit it all on one line. But it does get messy, in my opinion, when you have to go over the line. And it's just, I think, so much easier to just use normal functions, you know, if you want to. You can kind of break it up a lot easier. Anyway, it's obviously when you're capturing, it is overkill. It's much easier to use lambda when you're capturing. Creating a struct like this with members and all this, because all this goes when you use a lambda, and you just essentially have that line. So capturing is very powerful if you want to do that, but there are other ways of doing it. So let's look at another example. So say we have a lambda just like we had before. Another way of doing it is literally just create a function, obviously, and just pass in the array and the item you're looking for, and then iterate through the array until you find it. For me, that's a lot cleaner than the lambda example in this case. And there are a number of reasons for that. One is I might want to use this function a number of times elsewhere, and obviously if I'm using lambdas I've got to write it every time. Two, I usually don't care what this function is doing. I can usually just write this once and then never look at it again in the history of my codebase. So I can just put that away somewhere in some utilities file or whatever, or just the top of the file, or, you know, somewhere it doesn't matter. It's probably never ever going to go wrong, and I probably don't really need to know. I know what it's doing. I mean, this is a very simple example, obviously, but if you name your function well, it's very much easier to see what it's doing, I think, because you're reading a function name rather than trying to parse code. So I would argue in this case, I mean, it's a very contrived case, I know, but often I think it's for the same reason we use functions everywhere else in the code. If you've got a big block of code that's doing one very specific thing with very specific inputs and outputs, I would prefer to keep it as a function somewhere in the file, give it a good sensible name, and then you've got very simple code. Whereas to me, that's very complex code. And unnecessarily so, I would say. So say we've got that example, but this function becomes more complex for whatever reason. So I couldn't think of any code to put in there, but you get the idea. So it has to be over multiple lines, so let's split it and let's try and format it in a nice way. I have a real problem with close brace, close bracket, semicolon. that to me just looks very ugly when you're splitting it. So that bracket there matches up to that bracket there. That's horrible to me. I keep on forgetting to add these at the end, which is annoying. Anyway, something one would get used to if you had to. Anyway, that's a minor point. But the more code, the bigger the body gets, the more you would probably want to split that out into a function anyway, because having it inline in the code is suddenly less useful, in my opinion. And it becomes harder to parse because the code you're reading here is sequential and doing certain things like find. And then suddenly you've got all this logic about how you're finding it, and you might not want to know that. And when you've got lots of these functions doing the same thing, it's very easy for this test.find to get lost. So say I duplicate that a few times. Now that's another thing. Formatting always goes screwy in most editors actually. Anyway, you're kind of looking at all this code. I mean, maybe it's doing a different thing each time, and that's fine. But you're suddenly looking at all this code, and the most important thing for me is the test.find, because this is what you're actually doing. And that kind of gets lost. And so for me, I would prefer to split that out into a function and then call it, which obviously you could do. You could do that with a Lambda. You could call the function here instead. But my problem with keeping, like I said, two things, there's capturing and there's inline code. So when you want to keep the code in line when it's very short, and because when it gets really long, it becomes really unwieldy and it's very hard to follow what's going on. So Lambdas are good for when what you're trying to do is very simple and short. But my argument would be, if what you're trying to do is very simple and short, it's probably not that interesting. I mean, like this, obviously, this is a contrived example, but that's not very interesting at all. And if it's not interesting, why not just stick it in a function somewhere at the top of the file and forget about it forever and just have a nicely named function? So for me, there are very few cases. I mean, obviously there are cases where a Lambda might be useful to have it in line, but for me, they're so few and far between that I'd be adding a whole complex feature to my language, which I would only rarely use, and for very little gain. So anyway, that's my take on it. I know there are other takes, and other people definitely like them. So talking about a real example I saw in one engine. Oh, sorry, I'm ignoring the comments. So someone's saying that's called a functor. I like how Lambdas can be self-documenting, but being defined in the context they're used. For simple stuff anyway, exactly, yes. Yeah, so, I always forget functors. So, yeah, like you said, they're good for simple stuff. If it's simple, then it probably isn't that interesting, and maybe you don't need to see it in line. Anyway, this is one example I saw in an engine, and it was various kind of stuff being called in the renderer, like RenderPrimitive, for example. This is just a contrived case that I kind of came up with. And every time you called into the renderer, it would do the actual task on another thread. So it would call into some task manager thing, and this code here would obviously be executed on another thread. And in a way you could say, oh yeah, that's kind of neat. You call this function, the person calling the function doesn't care that it's happening on another thread, and then you can just kind of write this code as though it's happening here in this function, but it really gets pushed off onto another thread. And yeah, it's kind of neat, but what I found was that there were these functions scattered all over the code. There wasn't just one render interface file with all these in. these actual functions were scattered everywhere. So every time you wanted to render something, you would call all these render APIs, etc., and then just kind of wrap it in one of these things to say, oh yeah, and by the way, you're on another thread. And debugging it I found very difficult because if you're stepping through this function in the rest of my code, which is all running on the same thread, and I want to step through these, it's actually very hard because I can't obviously step through these. If I put a breakpoint in here, it's going to break on some other thing somewhere else. So conceptually for me, it was just very hard to sort of get my head around this was being called on another thread, because it kind of looked like it was inline code and being called there and then. And I think a much cleaner design overall would be to have one file, which is the renderer interface with a load of functions that you call, and internally it's black box, you don't care what it does. If internally it wants to add things to a task buffer, that's fine. But then all functions would be in one place, and you wouldn't have stuff, because if you want to say, oh, okay, what happens on the render thread, you've got to look through 100 different files and they're all doing different things. And when you're debugging, it's jumping around all different files, going to random threads, random files. It's very hard to keep track of. Having one very clean interface with all the render functions in it, and you know that if you're in that file, you're in another thread. So I do a lot of threading work in my code, and it's very important to conceptually remember where you are in a thread. So I would very rarely ever have more than one or two threads in a single file. And if I'm going into another thread, I'll make it obvious from the function name or whatever. And it's very easy to do this, but for me, it wasn't very easy to work with or to understand or to keep track of what was going on, because the render thread was defined like this in hundreds of different files. And for me, that's just bad design. So modern C++ does allow you to do things in a very powerful way that you might not need to do if you designed your code in perhaps a better way. That's my take on it. So I wasn't a big fan after using this kind of way of doing things for a while. What do you think of OpenMP? Once I improved 750 milliseconds to 150 milliseconds with one line of code. Yeah, it has its uses, but in my experience of optimizing code, it's very rare that you could ever just add one line of code and make things that much faster. And in isolation, maybe, but usually when you're doing threading, you've got to look at everything that's going on all the threads and have a proper design for it, rather than just sticking in a sort of clever command which suddenly makes everything go multi-threaded, like on a for loop or something. And in isolation, yeah, it's fine and it's cool if you can find a case that does that, but in my experience, it's very rare that you'll ever find a case where that's really the best option. But yeah, sometimes, possibly. But again, if you started using that everywhere, you would suddenly realize that if you're really loading up all the cores with doing things like that, you're gonna run into issues with thread contention on various resources and different cores trying to go wide at the same time. So threading is much more than just, hey, I'll go wide on this and that'll be really fast. You know, in a very simple case it is, and that's fine, but in a more complex like game engine, then it's almost always more complex than just sticking an OpenMP sort of threaded thing in there. So I think that's all I had on this file. Let's go to, let's just check my notes. Let's go, oh, we're here already, good. So hopefully you can see that clearly. So I thought I'd go through my own code base and try adding lambdas for stuff and see if it makes it nicer or not, or compare it and see how it looks. And I'm trying to be fair with it and not just come up with stupid bad examples that obviously don't work. So you can see what you think. So a lot of the time, as I've probably shown before, I've got the task manager where I add a task. It's good to be run on another thread. Question, do you use SIMD instructions? No, I don't really. No particularly good reason, I just haven't needed them. So someone's asking about how would you recommend a beginner intermediate C programmer? Oh, sorry, I really don't know. I learned C++ from one single short book about 25 years ago, and yeah, I'm sure there are loads of good resources on the internet now. So yeah, as I was saying, I want to call this find task function on another thread, so I just use my task manager and I pass in the function pointer. This uses one of my function classes, and then I pass in the stuff that I want to capture. And then I thought, okay, I'll try that using a lambda, see what it looks like. And again, this weird syntax that I don't know if I'll ever get used to. And it's literally just calling the function. So these are captured implicitly through the equals operator. And yeah, make up your own mind, which is clearer. I mean, obviously I find mine clearer because I've been using it for so long. But maybe someone who uses lambdas would find this clearer. I'm not sure. But there are a couple of things to know. One is that I had to declare this context outside of here, because obviously this in here is being run on another thread, and I need to create this context on this thread. So here I could just pass in directly, whereas here I need to create it outside the lambda and then capture it in there. So yeah, it's debatable. Maybe it's better, maybe it's worse, not sure, but it's not. I think you'll agree, at the very least, there's not a lot in it. You know, this is very simple to me. I'm just adding a task, passing in a function, and then two capture variables here. So let's go to second example. What was I doing here? Oh yeah, this is my main thread dispatcher. So I'm on another thread in this function. This is when the task finishes, so I'm on the other thread, and I want to actually do something on the main thread now that everything's finished again. So I've got a main thread dispatcher, which again just takes the function pointer of what to call, and that's calling that function down here. So again, it's exactly the same syntax as my other example. That's the function pointer, and then I'm passing in what I want to capture. Very simple, you agree. And this is the Lambda example I tried to come up with the simplest way of doing it. Formatting, I always find formatting lambdas tricky, but I think, you know, I know lots of people like to keep the braces on the same line, but you know, everywhere else I have them on a separate line, so I figured that was the best way. Yeah, I mean, again, I don't know if you'd agree, but I don't think there's a lot in it. I still find that weird, and I'm having to add braces and a weird close brace, close bracket, semicolon, whereas this is just a function call, like every other function call in my code base. So for me, that looks like an alien object, kind of weird. What the hell is that thing? Which again, I know would want you'd get used to if you're using it all the time. So that's not really a huge complaint. Just that the syntax is ugly. But again, I don't think there's a lot in it either way. So just by the laws of simplicity, I would go with my solution here, just because I think it is simpler, less syntax, and it's the same as almost everything else in the code base. It's just like reading straight C in a way. I think there was something else I was going to say. Yeah, about capturing. I think you've got to be careful when you're capturing, especially caching a reference, which I don't think you should ever do, really. That's dangerous, because you could be referencing something, a local variable, which obviously won't be alive once this function is called. But even just having an equals reference, that just means I can capture anything I like, and it's implicitly capturing those. So I'm not really declaring anywhere that I am, and for me that's kind of problematic, because with a function I like to know what inputs it takes, what outputs it takes. So here I've got a function essentially where I'm not declaring the input function arguments. You know, like here I've got a function, these are the arguments, I know it takes these two arguments, I'm going to do stuff with it and then return something. Whereas just with an equals and a capture thing, I can't see what I'm doing. It's not immediately obvious. I know I could write them in, even though I could do that, but then you're kind of losing some of the benefit and conciseness of the Lambda. And it's kind of like, well, if you're going to start doing that, you might as well just write a function. So anyway, that's just a small thing, but I think it's something you've got to be aware of. And I have seen quite a few bugs where people have captured stuff that they shouldn't be capturing, which is dangerous and goes out of scope or something like that. So anyway, let's go on to example 3. What was this? So I've got a quicksort function, and I'm passing in a comparer. Now this isn't good code in a way. It's not going to perform particularly well. I mean, this isn't using Lambdas, it's just my code. But usually you don't want to be passing in function pointers when you're iterating over potentially large amount of objects, because whenever you use a function pointer, you're going to get the overhead. It's like calling a virtual basically, because the CPU doesn't know where it's jumping to. So, but in this case, it doesn't matter. It's not performance critical code. So I just thought, okay, I'll just create a function pointer with this function, which is just down here, you see, and then just pass it in as an argument to the quicksort, which is fine. You know, that works. So then I thought, okay, I'll see what that looks like using a Lambda. And again, we've got to use the auto keyword. And we've got to capture this. So rather than just doing equals, I could just do equals instead of this, but I thought I'd make it clear that I'm capturing this in this case, because that's what I do up here. And then the function arguments, again, in this case, obviously you can see the arguments, so that's good. And then it's returning an int. And because this code is quite a lot, I obviously wouldn't want to put that in line. I mean, I could, but it's going to get pretty unwieldy. See, for me, that's what is it doing here? You know, oh, I just noticed this little quicksort thing down the bottom, but this is the main thing I notice, and I probably don't care about that in this case. You know, if I care about it, I'll go and look at it. So for me, I would never put that in line there, and I certainly wouldn't copy and paste that and crowbar it into this argument here, because that would be horrendous. That would be really bad. I don't even want to do that. But you get the idea. I'm not a big fan of huge swathes of inline code just because I'm clever and I used a Lambda. So anyway, see what you think of that. It's pretty much the same code. Again, I like this because it shows this is a function pointer with this return value and args, and this is the function I'm calling, and then I just pass it in. So for me, that is cleaner than this. I mean, obviously all this depends on having a function pointer class like std function or my one here. But you know, it's that or use a lambda. So it's really up to you. Anyway, so hopefully that gives you some. I think I had one more actually. Okay, so this is another quicksort example where instead of passing in a function pointer, I'm passing in a class, which is obviously faster because, like I said, you're not indirecting off some random pointer, jumping to some random code. So because it's a template, the compiler can work out exactly where it's going, and it just writes the code really optimally. So the comparer, in my case, the quicksort just expects a struct with a compare function that returns int. And the quicksort just passes in the values, obviously, and then you compare it. So this is a better optimal example of using a template in a sort class. And I thought I'd just do the Lambda example, trying to format it in the best way I can. It's not great, but that's the best I can come up with. And so this is the same code as in that function I just showed you. And again, you just pass in the comparer. Now this won't take a function pointer because this is templated. So there'll be equivalent performance-wise. And so I'm not using a function, a std function here or anything. It's literally just passing in a templated lambda, which is the same as passing in the class essentially, except this is static and the other one isn't. So again, if you really wanted the code in line, you could do that. But equally, if I wanted the code in line, I could take that struct out and put it up here. So that's perhaps easier to see what's going on. To me, I like that because I know what structs are. I use them all over the place. I know compare function, and this to me is a bit more complex, a bit more weird, but you know, not much in it. So it's not like if you saw this code you would think, oh my god, that should definitely use a lambda. Well, yeah, you could use lambda. It might be slightly clearer for some people who are used to using lambdas, but it's not a sort of slam dunk, I don't think. You know, it's definitely not. I wouldn't look at that and say that's bad code. So anyway, trying to think if there's anything else I can talk about. Anyway, just to sum up, I think you get the idea of kind of where I'm coming from. I don't think lambdas are inherently bad. You know, they're very neat. They're very good for capturing variables. So capturing is quite nice. But I probably wouldn't use them very often. And the times I use them all over the place like this, for me, they're not clearer. This for me is much clearer than this, and that's why I kind of just have never really used them. I've never had the need to. So as I was saying, so inline code is one benefit. You can have a function inside a function. I remember when I first heard about lambdas, and I was trying to work out what they were and understand them when they were first added to C++, and people would say, you can have a function inside a function, and it can use variables that are in local variables that are in that function. I'm kind of thinking, why would you ever want to have a function inside a function? It's like very rare that, because most of my functions that I'm doing are kind of big. I would never want that. and if they're small, why bother? So my reasoning is, if it's a large complex thing, it shouldn't be in a Lambda, because that just makes it too unwieldy. I think most people would agree with that. If it's really small and simple, you can kind of feel smart and whatnot when you write the Lambda and it's all there. But if it's that simple code, you probably don't need to see it. Just stick it off somewhere else and forget about it forever. So you've got to think, when you're reading code, what code do I actually need to see to understand this? Can I understand it just with a function name? Or do I really need to see the function body in with the code? Sometimes, yes. Occasionally it is useful. Like if you're doing a sort and you want to see the sort function, there with the code. Maybe, but I do that. I've done that a handful of times in my entire code base. So I wouldn't add lambdas to my language just for a few cases that might look a little bit nicer with a lambda. And obviously capturing variables is very useful, and it is nice that you can automatically capture stuff. But again, there can be problems using the equals capture, where you're just capturing everything because you're not explicitly declaring the things you need. So like I said, it's like having a function without any arguments at the top. And like I said, I've seen a number of bugs where people have captured something they really shouldn't be capturing because they kind of forget they're in a function. Or they forget they think they're in a function, but they forget that line of code is actually being called on another thread somewhere else. So you can't just capture anything you want. You have to kind of think about it. And for me, it just makes it too easy to shoot yourself in the foot. And also, usually lambdas are assigned to std functions, and std functions aren't particularly cheap, and they do a number of allocations, as I understand it. So that's not always ideal. So it's not as, the code looks kind of simple in a way, but there's a lot going on under the hood you're not aware of. And also, if you're capturing by value, you could be copying stuff that you perhaps don't realize and having an overhead from that. So there are a number of things to think about when you're using lambdas. And yeah, that it's just my take that I've never particularly needed them. I've never thought, I could really do with having this code inline in a function. It just doesn't ever happen. And I think a lot of the modern C++ features are there for other reasons. What I mean is, if you structure your code in a certain way, you'll probably never, like this example, you'll probably never need to do this, because you would have a nice renderer interface where all the threading is hidden behind an interface file, so you never have to care about it as someone calling it, and you wouldn't have these threaded things scattered throughout the code. So a lot of the powerful things that C++ allows you to do, if you just design your code in another way, you wouldn't need to do them. And I think very often structuring the code in a different way is a much better option than using a super powerful feature like this. I was going to say something else. I can't remember what it was now. Yeah, that's right. Because you've got to remember, like I said right at the beginning, C is pretty much the fastest language. I mean, any high quality library you'll come across that's been around for 10, 20 years will probably be written in C, and it will probably be super efficient and fast. You'll very rarely find a pure C library that is just horrendously slow, but you will find C++ libraries or code bases which abuse C++ and use all the new fancy features, and they will be incredibly slow. And that's because people are using complex features that they don't really understand what's going on, and they're sort of copying things around all over the place and making allocations all over the place that they don't realise, because the code looks deceptively simple, but it's not. It's doing very complex things. And often, like I said, restructuring the code is the better option. So remember, anything you can do in C++, you could do in C. You know, we could write everything in C. And I wouldn't use straight C anymore because I do find C++, like I was saying in the last stream, there are certain things I like about C++ because it allows a very slightly higher level of abstraction and to conceptualize things in a certain way and to group things in a certain way, which in C you end up kind of having to use these weird naming conventions to do the same thing. But remember, you can do the same thing in C. So you've got to ask, you've got to think, I'm not using C++ because it's faster. I'm using C++ because it's clearer. And if it isn't clearer because you're using complex modern C++ features, then what have you done? You might as well have gone back to C++, straight C. See what I mean? So that's the way I think about it. I always think about C++ from a C programmer's point of view, is what is this adding? Because usually it's not adding speed when you use C++. Usually, if you don't know what you're doing, it's easy to be much slower in C++. And it's very rare to sort of shoot yourself in the foot in C. So you've got to think, is it worth it? You know, is it worth using this complex C++ feature and potentially sacrificing performance and maintainability? So anyway, that's why I use C++ in the most simplified, basic way possible, only using the simplest features of the language, and very rarely ever really kind of pushing it. Occasionally I do, but it's quite rare that I will. So just looking at the comments, some good examples of stuff to learn C++, that's good. So GGN saying, I don't have any experience with Lambdas, but they just look like a parlor trick to me. Yeah, I mean, that was my initial impression. When I saw people first starting to use them in code, I kind of thought, it kind of just felt like people were using it to be clever, and you know, you have to be kind of clever to use them in a way, and especially the syntax. And yeah, I've just never seen a need for it, to be honest. So SPS says, I don't only use them when writing repetitive code in the same function to make it more readable. I don't like to call out to external functions in a routine if I can help it. Okay, that's interesting. I know some people like writing big long functions that do one thing after another rather than calling out lots, and that can be helpful, definitely. That's something else we could talk about another time, is how long should your functions be. And I have very long functions that don't call out at all. I mean, I've realized what I do with functions is I either have a long function that only calls out, or I'll have a long function which never calls out, if you see what I mean. I don't know if I can find an example of that. So for example, in 10x, I've got my initialize app. This is a pretty long function, but all it does is call out to other functions. I try not to put any logic in here. There's the odd line or two. But then I don't have to care about this function at all, other than the order of functions, which might matter. So, but if I didn't do that, I would try and keep everything in line rather than calling out sometimes rather than others. But I think the thing about the Lambdas thing is even though you're keeping the code in line, you are actually calling out to a function. So when you're stepping through in a debugger, it is going to jump around a lot and maybe even, you know, jump on another thread. So, you know, if you stick a breakpoint here, it's going to kind of randomly jump inside this other function and not do anything above it. So if I've got some sort of code above it here, and I step a breakpoint here, and this is on another thread, all of this is just noise above it. And I don't care about that. I don't want to see it because I'm in this function. So when I'm doing a function, I want to know that it's self-contained, so I can see the inputs, I can see the output, and I know it's totally self-contained. As soon as I do this, I can't see the inputs and outputs anymore. I don't know what I'm using from up here, and it's not self-contained anymore, and I've got all of this code creating confusion potentially. So yeah, I mean, this was just a bad example that I found. So I'm trying not to just create contrived bad examples to show why I don't like lambdas. I'm trying to be as fair as possible. So yeah, exactly. Lambdas can look nice when you write them, and nice and concise and clear, but when you're debugging them, I find it, again, it might be something you get used to. I mean, but I've been debugging lambdas for quite a long time on other people's code bases, and I should be used to it by now, but I still don't like them. So yeah, who knows? But yeah, I do find debugging with lambdas, especially threading, is pretty horrible. If you look at the modern C++ way of doing threading and tasks and stuff like that, and finalizers and all this using lambdas, and it's pretty horrible, to be honest. I mean, it's very powerful that you can write threaded code very quickly and easily in one single small amount of code. It's incredibly powerful, but it's incredibly hard to maintain when the threading starts to get complex. And when you're debugging, it's kind of jumping around the code to various different lambdas inside one another big complex function. And when I'm doing threading, like I've showed you in my examples, I like to keep things separated by function as much as possible. Let's find an example. So my find task, if something ends in task, I've just got this convention, I know that a task will run on another thread. So I instantly know by looking at this function that this is running on another thread. So I have to be careful about any members I use, that they're all thread safe. And if this was just some block of code in line in a function somewhere, it really wouldn't be clear that it's running on another thread, and I would just jump to the middle of some function when I'm debugging. So when you're threading, it's really important to keep things as separate as possible and make it very clear what's running on what thread and where. And I don't find lambdas help at all with that. You know, some of the most complex lambda code I've dealt with has been with threading, and it's just a complete mess. It's really, really horrible. And I've come to a really sort of nice way of, because I've got so much threading in 10x, that I now know exactly when I'm running on the thread and when I'm running back on the main thread. Like when I call the finished function from that thread, I know that I can just do a main thread dispatcher, call this, and I know that this is underscore main, so I know that's running on the main thread. And that's really, really useful to me. It's because it's so easy to make mistakes when you're threading. So you really do not want to condense all your threading into one function with a bunch of lambdas doing various things, because it's just horrific to maintain and debug. So someone says, I'd only call lambda in a function where it's defined. I wouldn't pass it on apart from sort functions as an exception. Yeah, that's fair enough. I mean, like I said, you can use lambdas obviously without threading, and that is better. And like I said, with the sort functions, that's not a bad thing. It's not terrible. It's just a matter of, do you like the syntax, and is it clear, really? So I want to say that I'm not just saying no one should ever use lambdas, or it's bad code if you do. The main point I want to make is you don't have to use lambdas. You can get by perfectly well without using them at all. And I don't think anyone would look at my code base and say, my God, that looks terrible. What you need is a lambda to make it look so much better. they might say, oh, why don't you use lambdas? Because you could do the same thing with a lambda. And, you know, in certain cases it might be slightly better. But I don't think anyone would look at my code and say they just can't understand what's going on because I'm not using lambdas. So it's not going to make a huge amount of difference, I don't think. And I just want to make it clear that you can program in C++ without using a lot of these modern features. And it's not bad code, and it runs very, very fast. You know, you're not going to sacrifice any performance by not using some of these features. So yeah, GGN, use things in moderation. My kind of rule is, if I'm going to use it in moderation, I'd rather not use it at all. Like I said, because of lambdas, there are only a few cases in my code base, like say the sort functions, for example, where I might use a lambda. Because I would use it so infrequently, I probably wouldn't get used to using it enough, and it would be a really complex new language feature that I'm using that I just wouldn't use that much. So I'm not going to use it in moderation. If I'm going to use something in moderation, I'm probably not going to add it to my language, and I'm not going to use it at all. Because for me, it's so important to keep things standard, as in everything looks the same. You know, this just looks like a function call to me, and that's fine. That's the way I like it. This looks like something different and weird that isn't anywhere else in the code base. So if I was only to use the lambdas occasionally, my rule is, well, just don't use them then. Because I don't want to add that complexity of suddenly coming across this weird looking thing. But anyway, that's just my opinion. But hopefully you can get something from that and just realise there are other ways of doing things that you don't need to use lambdas. They're not a requirement for being an expert C++ programmer. Right, so spot on an hour. So yeah, we didn't get through anything else really. Anyway, next time I'll talk about R values, and I might talk about enum classes a bit more if you want. And then maybe go through some more of my code, because I still think it's useful just randomly jumping around my code and showing things, because you can ask questions about stuff that aren't clear. And I think that's a really good way of learning as well. So I don't want to do too many contrived examples. I'm probably going to have to do a few more examples with R values just to explain them and what they are. But I'm kind of assuming you know what an R value is already, because this, like I said, this is not a teach you how to use C++ stream. It's more, how can we use C++ and what should we use of it? So anyway, I hope you found that useful, and yeah, if you do have any questions after this stream, or if you're not watching it live, then do email me, contact me, or DM me on Twitter or whatever, and then we can go through some of the questions at the beginning of the next stream. Or if you have any examples of what you'd like to see covered in this stream, then I can definitely do that as well. So, okay, if there aren't any more questions, I think I'll call it a night. So, okay, right. I'll see you again next time. Take care. Bye for now.